Alright, algebra people. So, this is your first video for this week. This week's going to be a little bit different. Rather than just me kind of doing some sort of lecture video and then having you work on a bunch of homework problems, I've decided to be a little bit more creative, and hopefully this is a little bit more fun for you as well. So, here's how it's going to go. I'm just going to start talking about some math stuff, and then we'll get you going from there, and I'll tell you what to do. So we're going to start with what you see on your screen right now, y equals mx plus b, which we developed in the last video that I made, and in our last class if you were there. If you remember correctly, hopefully this comes to your mind right away, but this guy, this m, that represented my slope, and this b, and it's important to note that this plus sign is included too. So if that were a minus sign, then my y-intercept would be negative. But this whole thing, this whole plus b part, that represents my y-intercept, or more specifically the y-coordinate of the y-intercept, since the x-coordinate is always 0, which we talked about last time. So we're going to work with this a little bit more now. We're going to see how it's useful. In our last video or class, whichever you saw or were at, I talked about how it's more helpful to be able to graph linear functions that are in this form, because given a slope and a y-intercept, graphing becomes a lot simpler. But this is useful for a lot more things as well. So we're going to look into some of those things today. So first of all, we're going to start with a pretty basic example. If I tell you that a linear function has a slope of, say, 3 and a y-intercept of 6, you should pretty easily be able to write down what the equation of that line would be, right? If I tell you the slope is 3, the y-intercept is 6, that means that my equation has to be y equals 3x plus 6. Because the 3 goes in the spot where my slope is, the 6, the positive 6, goes in the spot where my y-intercept is, and it's pretty straightforward. Now, I don't want you to take this for granted, because you've literally just developed an equation that could give you any point on this line. You could plug in any value for x, and if you were to evaluate this expression over here, it would spout out a value for y for any point that you plugged in for x. So this is powerful stuff, even though you might not really think it is. But there are some other things that we can do with y equals mx plus b that are even cooler than that, believe it or not. Say, I'm going to actually draw a picture here. And let's see. I'm just going to draw it in what we would call the first quadrant, which would be over here. And I'm just going to plot a couple of different points. Let's say I plot the point 1, 3. So if I just go out a little ways here, 2, 3, 4, 5. So 1, 3 would be right there. And then I'm also going to plot the point, we'll say 4, 5. All right, 1, 2, 3, 4, and then up 5. So that would be right here. Now let me ask you a question. How many linear functions, how many straight lines can you think of, just intuitively, don't think algebra, how many lines could you draw that go through these 2 points? Well, there's really only one, right? You could literally only draw this line. There's only one straight line that goes through any 2 points. And what that means is that if I were to give you 2 points, like 1, 3 and 4, 5, you should be able to write a linear function for this line that we've created here, because for any 2 points, there's only one possible straight line. So using y equals mx plus b, we can actually do that. Now here's the question, how exactly do I do this? Because I don't know the slope, I don't really know the y-intercept, and if I look at my graph, it looks like the y-intercept is kind of in between 2 and 3 here. It's not really obvious where that crosses, so I really don't know a whole lot, right? But I do have 2 points, and with 2 points, I can find a slope, right? So maybe that's a good way to get me started. Let's go ahead and try that. All right, so I've got the point 1, 3, and the point 4, 5, and say it with me now. What's the formula for the slope of a line? It's the change in y over the change in x. Hopefully that's stuck in your mind already. So from the 0.13 to the 0.45, x went from 1 to 4. As you can hear, my sickness hasn't completely gone away yet. So x goes from 1 to 4, which is an increase of 3, and y goes from 3 to 5, which is an increase of 2. So my slope, my m, is my change in y, which was 2, divided by my change in x, which was 3. So 2 over 3. Now you could put this in your calculator if you want to, but what you're going to find is that 2 over 3 is not exactly an even, you're not going to get an even number if you divide it. You'll get like 0.666 repeating. So what I would encourage you to do in situations like that is don't worry about a fraction. This is just a fraction, 2/3. I would just use that. So now, in our y equals mx plus b, for this particular line that we're working with, we know the slope has to be 2/3. So I'm going to plug in my slope of 2/3 into m. So instead of y equals just mx plus b, I now know that m is 2/3, so it'll be y equals 2/3 x plus b. I still haven't found b, but once I do, that'll be the whole equation for the line, right? I only need to find the slope and the y-intercept, and then I'm good. So now, what can we do from here? And I would encourage you to maybe take a minute, maybe pause the video, and see if you can figure this out on your own. If you want to do that, go ahead and try that right now. And all I would have you do is just see if you can find a way to find the y-intercept without just looking at the graph and kind of estimating it. Because if you can figure this out on your own, that would be kind of cool. So maybe give that a shot. But for the moment, assuming that maybe you gave that a shot, I'm going to go ahead and kind of give you some guidance as to how that works. So this linear equation, once it's finished, will give me any y value for any x value that I plug in, right? If I plug in an x, I'll get out a y. And I know that because these 2 points are on my line, when I plug in 1 for x, I better get 3 for y, right? Because the 0.13 is on my linear equation, right? It's on my linear function, I guess I could say. And similarly, the 0.45, if I plug in 4 for x, I better get 5 for y, or else my linear equation didn't work out right? Because both of these points are on my line, so both of those things have to be true. So I could really pick either of these points. Both of them would work. You'd get the same answer either way. But what I can do is I can plug in the point 1, 3, 1 for x and 3 for y. And I know that that has to be true in my equation. So let's just try that and see what happens. If I plug in 1 for x and 3 for y. So I'm going to plug in 3 for y, so that'll go here. I'll have 3 is equal to 2/3 times 1. That's what I'm plugging in for x now. I'm plugging in 1 for x and 3 for y. And then I'll still have my plus b out here, right? Well, I wanted to solve for my plus b, and if you look at this equation that we have here, we only have one unknown, right? We only have one variable. And with the skills that you already have, you should be able to solve this equation for this b. So, first of all, 2/3 times 1, you can probably see 2/3 times 1 would just be 2/3. So I really have 3 is equal to 2/3 plus b. And what would I have to do in order to get b by itself? Well, hopefully you're thinking that you just have to take this 2/3 right here and then subtract it over to this side. So let's try that. So on this side, I'd be left with 3 minus 2/3 is equal to just b by itself. Now 3 minus 2/3, that takes us back a little while because you'd have to get a common denominator in order to do that. So 3, because I have a denominator here of 3, I want to write this number with a denominator of 3 also. So hopefully this is second nature to you at this point. But that 3 I could rewrite as 9 over 3, because 9 divided by 3 is 3. And then if I subtract 2 over 3, I would just be left with 7 over 3. So I have to convert this 3 into 9/3 before I can actually subtract those two things. But in the end, I'm left with 7/3 is equal to b. So now I can take that 7/3 and plug it back in up here, right? Because I know I just solved for b, it was 7/3. So in the end, my equation is y is equal to 2/3 x, 2/3 was my slope, plus 7/3. And that was my y-intercept. So this is the equation of the line that has the points 1, 3, and 4, 5 that pass through it.